In this video, we are going to look at the combined gas law, which looks at the relationships that we saw in Boyle's, Charles, and Gay-Lussac's law and cleverly combines them into one equation. P1 V1 over T1 equals P2 V2 over T2. If we take a little bit of a closer look, Boyle's law is the inversely proportional relationship between pressure and volume, where pressure times volume gives you a constant. If you look down at the equation, P1 times V1 and P2 times V2 exist in the expression. And since temperature is held constant, if you divide both sides by a same temperature, you're going to see that you maintain that constant relationship. Charles' law is looking at the directly proportional nature of volume and temperature. Remember, if they're directly proportional, you divide. V over T gives you a constant. We're looking at the expression V1 over T1 equals V2 over T2. And in Charles' law, pressure is going to be maintained constant. And then lastly, we have Gay-Lussac's law, which is going to be the directly proportional nature of pressure and temperature, P over T to give you a constant, and likewise you end up seeing them as well in the combined gas law. P1 over T1 equals P2 over T2, and volume is held constant. So in essence, you can have all three variables change, or you can substitute directly into this master equation. Some students like to cross-multiply it out immediately and then take the denominator and the numerator of one side versus the other side to get P1 V1 T2 equals P2 V2 T1. Be very mindful that the temperatures are opposite of the pressure and volume. Okay, so if you have P1 V1, it's T2, P2 V2, it's T1. So next we will see a sample problem for the combined gas law. So this problem says, in the lab, a volume of a gas measures 725 milliliters at 28 degrees Celsius and 925 millimeters of mercury of pressure. What new volume will be established if the gas is placed under standard conditions? Standard conditions means STP, standard temperature and pressure. So if we start writing down our variables, okay, up here, 725 milliliters is V1, 28 degrees Celsius is T1, 925 millimeters of mercury is going to be P1. The new volume is unknown, V2, and this is obviously our T2 and our P2. So let's write it out. P1 is going to be 925 millimeters of mercury. We have V1 equal to 725 milliliters. T1 is 28 degrees Celsius. P2 is going to be standard conditions, which is going to be 760 mmHg. I want to choose the same unit, which is why it's again important to remember our pressure units. V2 is unknown. T2 is standard temperature, which is 0 degrees Celsius or 273 Kelvin. And as we have seen in all of the other problems as well, when we substitute into P1 V1 over T1 equals P2 V2 over T2, temperature cannot be a zero, so we need to be in this Kelvin temperature scale. So let's go back to our original givens and look at our Celsius temperature, add 273, grab our calculators, go and get one. 273 plus 28 gives us 301 Kelvin. Okay, for these problems, I really like to substitute everything in after we isolate the variable that we want. It's just less writing. So if we cross multiply and divide, and we are solving for V2, and keep that in mind, we get P1 V1 T2 equals P2 V2 T1. So again, I want to get V2 by itself. So what do? I divide both sides by P2 and T1. P2, T1. P2, P2, T1, T1 cancel out. I get V2 on one side and P1, V1, T2 over P2, T1. Oh, the algebra. So now that I have isolated V2 by itself, I'm going to plug in all of these numbers over here with my given in the right spot, and then all I have to do is type them into my calculator. So I get P1 925 mmHg, V1 725 milliliters, T2 over here, make sure it's T2, 273 Kelvin, divided by P2, which is 760 mmHg, and T1, make sure it's T1, 301 Kelvin. That equals my V2. So once I have all of that in there, I'm going to see units cancel out, Kelvin cancel out, mmHg cancel out. My volume will be in 725, or it will be in milliliters. Okay, so I'm prepping that. So how do I plug this into the calculator? Just like we did all of our dimensional analysis. Every number on top, you multiply. If it's in the denominator, you divide. Denominator divide. So in my calculator, I would put 925 times 725 times 273 divided by 760 divided by 301. And your answer should be 800 milliliters. Push pause after you get your calculator and try it out. See if you are doing the math. Very important to divide by 301 and not multiply. If it's in the denominator, you divide. So here we see the work is written out for you again, isolating the variables, making sure that we change everything to Kelvin, and we have the exact same pressure units on both sides. Here we have it all plugged in. This way is done where you are going to calculate it afterwards, after you have it all plugged in. So let's see.